I think I fixed the stability problems in our simulator. Our little ball simulator from yesterday. Look at this. Look at that shit. God, it's sick, dude. It's sick. So I think what I want to do, for as a recap, we were trying to solve a problem that we were having in our code map. Where actually I think we can just run viz here. I think we don't need to get into the environment. Here we go. This guy. So we are trying to show hierarchy of code, I guess. So this is like the repository of our image editor. And you can see that there are colored backgrounds for things, right? Green is all like UI related to like app specific UI. Orange is like OpenGL abstractions. Yellow over here is like text rendering. Red is math, right? So you can see there's like some sort of hierarchy here, but there are kind of like clumps in this hierarchy in these sections, I guess. And so we were trying to solve the problem of how do we set a background for these things, right? So each of these things, we kind of want like a background that we can like use to identify like what this section of the thing is, right? So like you can imagine you want like something like this gets a little complicated where you probably have like, you probably want something like this. And so we have been using Voronoi diagrams for the overall background, which basically says for every pixel, how far am I from my closest point and which point is that? And we use that to filter colors. And right now we don't really use that depth information or like that distance information. But we could do the same thing here where we say which point am I closest to, also how far am I, and if I'm farther than some distance, nah, we just won't draw anything, right? That's how we could get these kind of backgrounds. There may be other ways, but that's kind of like the first thing I thought of, right? So to do that, we need to set some sort of like threshold distance. And so my thought was, looking at these, that like hand wavy, we probably want it to be related to like kind of distance between points, right? If the points are more spread out, like if this was all one cluster over here, this is more likely many smaller clusters. But if this was one cluster, we would kind of want the distance to be farther than if it was these, right? Because these guys are like really tightly packed. These are like far away. We want to make sure that like this hole in the middle also gets filled in. So I was kind of thinking, okay, let's like try to find some sort of like average distance between points, right? And in order to do that, I was like, okay, let's approximate these things as a circle, track like their minimum, maximum X position or something. That will give you like a diameter of like of an imaginary circle. So like you could do something like, something like this. And you could imagine that probably average distance between points is probably related in some way to like number of points in size of the circle. And I was like, I don't really know how those are related. So the obvious solution here is we take a bunch of points, shove them into a circle, and graph their distances. But then I was like, how do you do that? Because like, I don't know. So we built this physics simulation yesterday that drops a bunch of balls into a bigger ball. And it wasn't quite this fluid yesterday. I made a couple of tweaks. I increased the like number of physics steps that are happening. So basically every second I just do a lot more samples. And then I also reduced the amount of push that the container does to keep balls in. So it'll like push them in if they're like less than half in now or something. But if they're like over halfway out, it doesn't try to like yoink them all the way in anymore. So what I want to do today is I want to generate the graph. Let's generate the graph. Rebel Elder, thank you for the prime. Much appreciated. So what I'm thinking is, first of all, we need to like speed up this simulation. We're spending a lot of time doing calculations for collisions from objects that are just like in like a giant pillar like this. That's kind of silly. So I think that probably what we can do is we can just start by like, I imagine you could just do something like this, where we take like one ball and we kind of, this is going to be hard to draw, but if we just like make a grid of these things, like like we just kind of take a grid of balls and we put them like this, right? Like just kind of like covering this whole thing. I figure that most will kind of stay inside, and if they're not packed like optimally, we can put some more on top that will like fall in. And hopefully that will give us like a converge on an answer of how many balls fit in the bigger ball, like very quick. And then we can just like rip the simulation for tons of different ball sizes and see how many fit. So let's start there. So how do we do this? New window, next shell. I wonder if it'll be possible to run war simulation between all these points. What do you mean by war simulation? Dude, we're just applying gravity. Okay. So let's just like adjust the initial layout of these things so that we do what? We have the container radius, we have the ball radius. So we probably want to do something like iterate over, we probably want to do like cell size is probably the container radius over the ball radius. Ball radius out of the container radius. Hold on. No, this is the cell size is just the ball radius times 2, right? I guess. Right? Each of these guys is going into a cell. We're making like a grid of these where balls live in these slots. Womp, womp, womp. So the cell size is known. It's just like 2 times the radius, right? Boom. But the number of cells is not known. So num horizontal cells. Did I hear gravity? What's next? Did mitochondria are the powerhouses of the cell? Dude, somebody has. This is, I think you've said the same thing 2 days in a row. Someone just hit grade 10 science, dude. He's really into it. So this is. We probably want to seal this. And then we want to cast this to usize, probably. I just find it stupidly funny. That's fair. It is kind of funny. Okay. So I guess we want to go like, we want to keep the height here, but instead of starting it above the container, let's start it at the bottom of the container. So we'll start at ball radius height. Guess what my first message tomorrow is going to be about? Kind of unknowable, probably. I guess we'll have to wait and find out. So I guess while height is less than some amount, let's just do this for now. I'm sure that will have to increase. We iterate over the number of horizontal cells, and we probably set the like X position to something. We probably want to do like, we want to center. Okay, hold on. We have, this is 0 in the center. That's what we just said. Our X position then needs to be offset by half the number of balls. Yeah. Times cell size. Yeah. With floating point precision, probably. So we'll start at 0. X minus equals num horizontal cells. X divide equals 2. And then I guess we could do this. From float from int, net num horizontal cells. And maybe something like this. Is that right? Yeah. Yeah. I guess times also the ball radius times 2. So it's actually like weirdly like this. We'll just put a note here. Half offset by half of total width. Total width is ball radius times 2 times num horizontal cells. Yeah. Uh, twos cancel out. Okay. How'd that WASM go? Did you get the number of balls in the bigger ball? We're getting close. We're getting close. So here I guess we're gonna say like x. This is a bad way of doing this, huh? We should do this by like indexing. Because like we know that if you continually plus equals a float, the like imprecision stacks, which is kind of shit. We could do like integer math and then convert to a float at the end. So here we use like the x index. And we have to calculate now the x position from that x index. So what does that mean? We take like, we do x is x index times something. Probably the like ball radius times 2. And then we need to subtract the half the offset. Yeah. What was it? Times ball radius? Yeah. Something like this. Yeah. Sure. Then what? We probably want to do the same thing for y, right? Oh, that's fine. So here now we need to keep track of the ball ID, I guess. And I would probably also have to limit while this and ball ID is less than balls. Then we can kind of set this. And then here we increase the height every some amount of times. Okay, cool. I guess here also we have to break out of this inner loop. Starting early today? Yeah, I guess so. A little bit. I just kind of wanted to start moving. Still going with physics simulation? Yeah, we're just trying to get it to we're trying to speed it up now. It's like the simulation itself is working pretty good. We're just like trying to adjust the init parameters and stuff. So here I'm trying to like lay out the balls in a grid over top of the bigger ball off rip, so that we don't have to run as many steps till it finishes. Looks good, yeah. Pretty happy with it. Looks like a maybe. Hello? Am I in the right folder? Zig build? Maybe I need to fucking go into here and hit disable cache. That's annoying, but I guess so. I guess so. So why are we getting nothing now? We can log the X position. Maybe we do this. I mean, those look like reasonable numbers. Negative 20, negative 220, 0, 360. Like, I feel like we should be at least seeing, like, something. We should at least be seeing something. Oh, here. Okay. So what's going on there? Num horizontal cells, container radius over ball radius. Okay, that seems like it should be fine. While height is less than container radius times 2, and ball ID is less than num balls. Okay. Okay, then we go over each horizontal cell in this thing. We set its position. So here we should be seeing like I feel like we should be seeing like a row of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like what am I seeing here? If it's not this. This is strange. Haven't been able to watch as much recently, but it's nice to see that the square wheels are still being pumped out. Hell yeah, dude. Like, this is so strange that we're only seeing one column. That is just a very strange behavior. Unless I've got like units wrong somehow. Can we log like what does ball positions look like here? Are we just doing like something dumb? That's interesting. Why is this full of 40, 20? That would probably do it. That would probably do it. There we go. That's kind of what I wanted. I don't know what this ball here is. This one at... Oh, there's... I see. Because we're not initializing all of the balls. So a lot of them are kind of staying at the 0, 0 position. Okay. So that... We just need to make sure that this num balls thing... we probably want to update this with like the actual number of balls. So we probably want to rename num balls here to like balls capacity. And then we want num balls to be the number of balls like in the simulation. And then on init, we say num balls is equal to ball ID. I just joined and balls capacity is the first thing I hear. Hell yeah. Okay, which means that probably in index.js you have to be a little careful about num balls being extracted before initialization. But otherwise, I think we're good. Can't access lexical declaration num balls before initialization. Fair. Okay, sounds looking good. I feel like we fucked up width by 1. That's kind of how I'm feeling looking at this. Or we fucked up the X adjustment here. I don't really understand how, though. I'm assuming this isn't it. Yeah, it's still, everything feels like offset to the left. So, what's going on there? Why? Why does that fix it? I don't understand. So we start at in the center. And we have to offset by something about this I'm not 100% sure about, but I guess if it looks right, it looks right. Usually I'd be feeling a little bit more rigorous, but right now I'm willing to just kind of let it go. Okay. Now what? Now we run the simulation. It's gonna be pretty funny if the answer was just like, it's a square. Whoa, what just happened there? The fuck? What just happened? Can we just go like way the fuck slower? So how does this work? We say we ran at some time. Let's, I guess we just can run 100 times slower by doing that, I think. I think. It looks like it's like unstable. Like everything's just like exploding. What happens if we start these, instead of starting at height of 0? What if we start them like up in the sky? I don't understand what's going on. Like, why aren't these starting above? Am I high? I might be. Oh. Oops. While height is less than container radius times 4, I guess, is the answer here. There we go. And okay, there we go. So now if we run the simulation again, does it like work? The fuck? It's so strange. I don't understand how what changes we've made should have any effect on that. I really don't. I really don't. I guess we did change numballs. Oh. All of the balls that are no longer being laid out initially are all invisible at this position, but still participating in the simulation. So they're like fucking just like knocking all of the other balls out, I bet. I bet there's some sort of like mega explosion at that point. Which means that here we just have to be careful about using ball's capacity anywhere. It should literally only be used on initialization. Everywhere else should be non-balls again. Okay. There we go. Hell yeah, dude. And that looks successful. Okay, so now let's go back to starting them inside. Oh yeah, that's sick. So like almost like instantly converges. Sick. And that means that the answer is like, we don't need to like stack items on top or anything. It seems to like fit pretty well by just doing that. It's kind of fun. Okay. What if we add... How do you count the balls inside? Haven't got there yet. But I'm sure it will just be like, after some amount of steps of the simulation, we just check the position of all of the balls, and we go like, are these within radius from the center of the container? I'm pretty sure. Pretty sure. Okay. We'll say layout, initial layout improvements. Okay. Next, I want to add a slider in HTML land. First of all, is this thing zoomed out? This is kind of his like full screen size. Can we make him not like 800 by 800, but more like 400 by 400? Maybe that's too small. 600 by 600? I keep zig building there. Okay, cool. And then we could do something like we could put sliders on the right, maybe? How the fuck do you do that? I guess it's like you do div here, and then you put like the top level at like display flex. Right? How do you do that? Or like a grid, maybe? Class equals like top level. And then what do? We do like style. That's a weird auto formatting choice, but fine. I guess I don't really know how this shit works. So can we just like put a couple sliders in here? How do you do range, I guess? And is it like this? Yeah, so we have this slider here now. Hell yeah. And now we want this thing to be on the right, I guess. So we want to go like, okay, get this shit out of here. Style editor, and we say like top level, display grid. Then how do I like say that I want 2 columns? Bruh. Am I crazy? Grid template columns. I feel stupid. This is why we're doing happy hour today. So this guy has display grid. Then why is this guy like not on the right? Do I have to do this? Oh yeah, that seems to do it. Okay. Why? So the default is something else, I guess. So what's 1FR in here? Widths of columns. Values are space where each thing says 1 width. Okay, what the fuck is 1FR? Fractional unit. Sure. So you're saying we could use auto there, and that probably also does what I want? Yeah, I see. One for real, on God, on God. Okay. That's good enough. We don't have to be perfect. Uh, and then how do you do this? You go like label. And you say like numballs. Is that right? Do I have to do label 4? I know that I've seen this before. Doesn't really seem to change anything, but maybe that's good anyways. Is it normal for this to be like so fucked in unaligned? Is this what it's supposed to look like? Am I doing something fucking brain dead by doing it like just it looks so bad. uh Input slider HTML. Am I like fucking stupid? Okay. It just looks like ass. Okay. That's fine. Do I want a slider? I guess so. And then I probably want to set like its min and max values. Sure. I mean, 1 in 100 is not crazy. So we need to like get that thing and attach like some sort of callback to it. Are we making more balls? Hell yeah, dude. Look at this shit. Look at this shit. Wait. It actually, I don't know why my browser is just like fucking up. Oh, there we go. Boom, 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 boom. It's perfect. So I think that we're pretty much at the point now where we can start like tweaking it, you know? Numballs. Get element by ID, numballs. And then we probably do like numballs. Can we get like crazy here? Type is HTML input element. Oh yeah. And so we can say like on change. Sure. I guess on this has to come down here because it has to be done after the WebAssembly module is instantiated. Numball slider, I guess. And surely we just have to call some WASM function that will change the number of balls. Oh wait, I don't want a num ball slider. I'm fucking high. I want ball size. We're going the other way. And then I guess it probably makes sense to display the value as well. Dude, my fucking brain. It's so not on today. So I guess we just do like. Why does it not show the fucking value? What a shitty UI element. I guess it also doesn't matter. Fuck it. Fuck it. Ball size slider. So surely this is like set ball size. Or I guess we just reinitialize this thing. Yeah. It's like something like this, right? Okay. It's kind of sick. Wait, that's actually kind of lit. We need to probably change the rendering here so that the outline is like proportional to the size of the ball. And then we also have to change like the maximum number of balls probably. Uh Yeah, let's change the rendering. Not that it fucking matters, but you know. Shouldn't the balls all stay inside the ball? Well, no, because we spawned some of them outside. Because what we're doing, if we just turn off the render frame for a second, or maybe if we turn off the step thing, or maybe in step, we stop calling step. That's probably the easiest fix. What we're doing here is we're like making a grid of balls that fills the circle, like fills the square that the circle sits in, and then some of the balls will like get ejected because we're trying to figure out how many actually fit. And it turns out that the answer probably is easy. Like this strategy is making me think that the answer is pretty easy to figure out. We didn't figure that out yesterday, you know. Okay. Let's also set the initial position of the slider. Is going to be no balls? Probably no. I guess we just do this. I guess we could set this value in HTML instead, actually. That probably makes more sense. Is it not value? I don't understand why that's not getting highlighted. Oh, probably because here I forgot to copy this with it. There we go. There we go. And then in HTML, we just set this thing to like 20. There we go. Nice. Wow. Okay. So what we're doing, we're going to change like the outer radius, the line width rendering. Ball outline width is like the ball radius over 10 or something. Okay, and then we arc from the ball radius minus outline width over 2. There. Sure. Yeah, but I want it to be bigger. Maybe 5. I keep trying to build, which is kind of fun. Yeah, that looks like better. All right. Sick. So I think that this is functional. Okay, and now all we have to do is like up the max number of balls. Do I have to do Control-Shift-I to get the cache disable to work? Oh, that's really railing my computer. Yeah, so it's probably trying to run the simulation at a certain rate to catch up to the current time, and it literally can't run it that fast. That's kind of funny. So I guess we probably have to adjust the like number of steps taken just based off like how many that can actually be done. So instead of doing this, while this, I guess we need some sort of way for this to like give the fuck up. Time to divide the space. Oh, like I mean, we could do some sort of like hierarchy where we only do collision checking with things nearby us. That would make things a lot easier, right? Because then instead of being like n squared, it would be like limited in some way. But I think instead I'll just let it go slower. Which means what? Do we just like? I guess we just give it like a max. That's fine. Hmm. Hmm. Is 100 to like? Yeah, there we go. Okay, 10, 50. I guess the problem is that like as we get a lot of balls, it like literally can't handle them all. This is weird too. What's happening here? That was very strange. But it's not reproducing. Oh, I wonder if there's like I wonder if there's some sort of like race condition here where we're like reinitializing between steps. No, surely everything's single threaded. You're gonna need de-optimize soon? Yeah, that's a good point. Huh? Oh, that is a lot better, huh? Okay. And then I guess um let's let it go up to like 5,000. Why release small over release fast? Somebody told me at some point that it compiles faster. I feel like there still aren't enough balls. Is that really 2,000 balls or 5,000 balls? Surely not, right? Surely that's not 5,000. Fine, we'll release fast. We'll compare. I mean, definitely when I do move the slider down, it does start to get like unbearably slow. So it feels like something must be happening. Maybe we should set like a min ball size as well for now. Stop. Hmm. I mean, I guess we could do the math to figure out. It does look like we're just losing a lot of balls off the edge of the screen immediately, which makes me think we should start the height maybe at like container radius. That way, like, at least things should all end up at least trying to go in the ball. There we go. So at least we're not like wasting compute on shit we don't care about. And I don't think that things are just like exploding off rip. I think that it could just be that we actually need more balls. I guess it would be nice to set a like known size as well. Yeah, display ball count. Yeah, you are thinking the same thing as me. Actually, I want to display ball size. Output. Okay. Maybe like this. How do you fucking just like put like text? Whatever, div is fine. Uh, so here we'll say like ball size output is equal to document get element by ID ball size output, and we just say ball size output inner HTML is equal to EV target value or something. Yeah, like surely like this is a problem. I would like to run the simulation slower. What do we say? We like pretend that each step was longer than it was or something? Okay. Yeah, there's something like exploding, huh? Maybe we just need to add bigger gaps between them. Maybe we just need to add slightly larger gaps. Slightly larger gaps. So can we just do like this? See, like what am I missing here? Like, are we doing something like Brain did with ball ID? No. Like, what am I? Num balls. So when we apply physics, apply ball collision, everything is like based off a number of balls. So the question is, are they like going into the fucking nether? Or are they like literally being removed from the simulation? Let's go back here. And just completely say, fuck off, we're not going to be doing this at all. Okay, so first of all, how many fucking balls is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8. 28 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Holy shit. What up, guys? Big raid. 300. Yeah, that's like fucking nothing. That's really not that many. So where the fuck are they all going? Yeah, what's up, everyone? Prime, thanks for the raid. That's really exciting. What's up, everyone? We are working on a physics simulation where we're trying to figure out how many balls are in another ball. a simple problem, right? Why are we doing this? Well, because we're working on this like code visualizer. We're kind of like deep in like the fucking yak shaving rabbit hole. But we're working on this code visualizer, whatever you want to call it. So we're actually working on an image editor. Okay. We're several stages deep right now. But we're working on this image editor, and this is an attempt to visualize the code base of our image editor, right? So what you are looking at here is every single little little like white fly in this graph is a function or a type or a file or a folder. They are kind of like we kind of like just take all those guys, slap them onto the table, right? And we say like, okay, go try to like go close to people who are you reference you, right? Like who you interact with by like calling code, or that you are like a child of, right? So if we like kind of like focus in on one section, I can kind of like hover here, and like all of these guys are just like the button class in my GUI framework. Or over here, this is part of the text box class. The idea here is eventually that like if we are working on some area of the code base, we want to be able to like focus in on like the parts of the code base that are relevant, right? So this is kind of like a in progress visualization, but we're trying to make it so that we will hook up Vim to this thing, and Vim will track who he is spending the most time on. So like we'll do like a rolling average of time spent in different areas of the code. And the hope is that we can maybe show at a glance how what we are working on at this second relates to the project as a whole, because as we get deeper and deeper into these projects, there's more and more code, and it becomes harder to follow as I jump around. So we're kind of hoping to like have some way of visualizing how what we are working on and how it relates to like the global thing, right? And so that's what this like background is like. The background is like a first attempt at this. We are trying to say what folder do things belong to. So the blue things are all in the GUI folder, yellow is all in the text folder, purple is all in the image editor folder. But like there are kind of like smaller groupings than this, right? So like this section all here, this is all related to like the box widget or whatever, it doesn't matter. This is all related to the label widget. And so it'd be kind of nice if we had backgrounds for those things too, because eventually we're planning on doing some sort of like fancy background that's like masked by this stuff. Like if like I've been looking at like Galaxy wallpaper as inspiration for this shit, right? So like you could imagine that like you kind of color different sections according to what part of the hierarchy they're in, and maybe you like get like more saturated or lighter the higher up the hierarchy you go or something, and then maybe you can like put a legend of like, oh, this color in the hierarchy is this folder or this class or this file, whatever, right? That's kind of like the idea. Now, how does this relate to this? So we, for each pixel in this diagram, are saying how far away from a given point are we? Which point are we closest to, and how far are we? Which is like actually like surprisingly easy to calculate on the GPU. You can like kind of leverage some 3D geometry to get that calculation for free. And so since we have distance, if we can find a reasonable distance threshold to say, okay, if I'm farther than this amount, I don't really care about drawing the background. We can maybe do something like in here, we could say like, oh, you know, if I'm like close to this thing, I'll like draw my shit. And if I'm like a little bit farther away from that thing, I won't draw that shit, right? And so the question is like, how far is a good distance? And so to solve that, I figure like maybe average distance between points in a cluster is like a reasonable approximation, or like a reasonable threshold. Maybe like times some multiplier, maybe with some fall off, I don't know. And so and so, I kind of figure like that's probably pretty easy to calculate if we kind of draw a circle around this thing and assume that the points are evenly distributed in this circle. And then I was like, okay, so how, like, surely there's some sort of like really cheap way to calculate that, but I don't know what it is. And so I was like, well, I could make something up, but how would I know if it's right? And so I was like, well, what if we built a physics simulation that dropped a bunch of balls in a bigger circle, and then we graphed how many balls fit in the circle? If we graph how many balls fit in a circle, then we can like look at the shape of that graph and figure out what the right formula is. I could have Googled it, but that's not as fun. So this is where we are now. Yesterday we got this simulation like kind of working. I think it works okay for like bigger ball sizes right now, so we can kind of show you. I think. Right, so this is kind of like, you know, an example. Some of the balls are leaking out already and stuff, but like, you kind of get the idea, right? We're kind of hoping that if we just like throw a bunch of balls into this hole, we can eventually get the correct level of packing for this thing. And then if we get the correct level of packing, we can write down how many balls that fit in, and then we can graph it, and then we can figure out the formula, and then we can apply the formula to the Voronoi diagram, and we can use the Voronoi diagram to draw pretty backgrounds on our fucking code diagram. And yes, how many balls can you fit in is essentially what we're talking about. Can you explain that algorithm? This one? This is like, we just like kind of say like, which algorithm? It really depends. I guess it depends on which one there's like the algorithm here, which is not that crazy. We basically go like every step. Who am I touching? If like my radiuses are like overlapping, that means we're intersecting. So like kind of like just try to apply a push in that direction. Hand wavy. Hand wavy. I guess I'll post code for this. That's probably the easiest way to like show it. If you're like really curious, you can take a look at this repo, and then you can also take a look at this repo here, if you care. Anyways, so that's the long chain of operations that ended up with us where we are, and this simulation was like working decently well. I think if I oh, wrong folder maybe. I think it was working pretty decently. Zig build, hello. Fucking disable cache, refresh. Yeah, like it was working pretty decently at a point, but then we were just trying to add in like a slider that lets us change the number of balls, and I think that was starting to cause problems. I can't remember. That's where we were when you guys rated. Anyways, welcome. Hope you guys had fun at Prime Stream. Happy to have you. Hopefully you find what we're working on interesting, but I'm just going to jump back into it. Enough catering to the new people. And back to our regular scheduled programming. Oops. Back to our regular scheduled programming. Okay, so first of all, why is this all of a sudden now not all staying in? It looks like because of the gap we added between the balls, do they have time to like bounce down and up? Boom. Yeah, I think that maybe because of the gap we added, I mean, we can confirm this. There's like more time for them to escape. So let's go back to ball radius times 2. Hello? Dude, how the fuck do I fucking get my WASM to load? This fucking shit, dude. Yeah, so it does look like just by increasing the distance between them, you need a simulation slider to step the simulation back and forth. I don't think that I can step backwards. I guess I could record every step. And like, just, yeah, we could like record the first like 1,000 steps and then like write them down or something. But I think I'm fine with just kind of refreshing. It doesn't really matter. Okay. So yeah, it looks like just by adding a little bit of padding between rows, fuck. It totally changed the behavior. So what is happening there? Maybe we should add a slider to change the simulation speed at least. And we can kind of leverage that to do something. Sim speed. And maybe with its value, it probably caps out at like 1. And I guess this is max. And minimum value, I guess maybe we like cap it at like 3x speed. Min of like, I don't know, 0.0 to like completely pause it. And then the initial value is going to be 1.0. And then do I have to specify like a step size too? Do I get, is step size legal or is it always integer? How the fuck does this shit work? Max, min, step, yeah. Okay, cool. Spheriphoria, cache bust, ASM load with adding my wasm.wasm cb plus. Oh, you're actually answering like a useful question. Like, I thought that you were just throwing like gibberish into the fucking chat. But you're saying if I throw a plus date now on the URL bar, it forces a reload. Okay, sure. That seems pretty reasonable. I don't know like how that works, if that like does what I want. Do you have to do, is it plus at the end? Don't I want like a question mark for query parameter? Where the fuck do I load this shit? Oh, it's just the wrong file. Dude, my brain is so slow today. So like, you do like now equals date now, which forces it to refresh every time. Is that correct? Yeah. Hell yeah. And then hopefully that means that I can fucking make changes without it being a problem. Okay. Sim speed. How does a container work? Does it have a timer it closes on the captured? Does it have a timer it closes on the captured balls? Oh, I see. We'll draw it. We make it so that we have like container, right? Balls out here, right? The collision logic is essentially like this does nothing because the center of the ball is outside of the thing. We also check as soon as the center passes the corner, we do a velocity check to say, is there a positive velocity towards the center of the ball? If so, then we do nothing. The only time we actually like try to contain stuff is in the condition where the center is inside and the velocity is somewhat going away from the center. Right? So like this would count, this would count, this would count, this would not count, this would not count type shit. So it just lets stuff end up going in, like it lets things fall in, essentially. We were having problems with this yesterday, and I was like laughing to myself last night walking my dog. I was like, dude, if we switch to a 3D simulation just so that you could do like a bunch of marbles falling into like a platter, it would be so funny if that's how we solved this. I mean, it turns out that we didn't need to do that, but if we went down this route, it would be like such a deep, stupid fucking rabbit hole. It'd be so funny, but not worth. Because they can just fall out with this constraint. What dog do you have? I have it's a golden doodle, I think they're called. Some guy at the park was like, yo, want my dog? And I was like, yeah. And now I have a like poodle golden retriever cross. It's sick. Okay. Wait, no way. I mean, nice, you got a stolen dog. Okay. I mean, I'm obviously kind of playing it up a little bit, but it's also not entirely untrue. I mean, I like went to the guy's house and like gave him money and stuff. So like I don't think it was stolen. So asking the real questions, did you pay the guy? Yeah, I gave him money. I think that it was just like my read on the situation after going to the guy's house was they had a lot of money. They wanted a nice easy dog. They found out that dogs are work. And then they were like, "Oh shit. This is too much work." And then I got it. He actually stole your dog. Erase your memory of ever having a dog and sold it back to you. Probably. That's actually like the most likely thing. What the fuck were we doing? We were trying to slow down the simulation, which means that like this multiplier here needs to come from somewhere. Speed multiplier. And we need like var speed multiplier is 1.0. And then when the speed multiplier changes, sim speed, I think we called it. We update the speed multiplier. So like this, I think. Maybe. It's like there's a non-zero chance that works. Nope. Speed multiplier. Over speed multiplier? Oh wait, yeah. Oh, come the fuck on. It gets stuck if I ever put it all the way to 0 though, which makes me think there's like some bug there. Probably because I'm dividing by 0, right? Yeah. Speed multiplier is greater than 0 and this stuff. Yeah, there we go. Hell yeah. Okay. So now we can try to figure out. Refreshing doesn't seem. Oh, because we don't actually take the value from the slider off rip. So we probably need to do like sim speed slider is equal to this. We do sim speed slider on input, and we also seed the initial speed multiplier with the initial sim speed value. That should do it. There we go, baby. Okay. Dude, it's so easy to miss. Okay. Yeah, okay, that makes sense. That makes sense. Um, so like the things are kind of like getting shoved in from the outside, which causes everything to push up, which causes like a bump up and an explosion outwards. So we could probably fix this a little bit by reducing the like. I suspect that if we reduce the like initial horizontal spread, I think that that will make that less of a problem. Um, do you have your dot files public like the neovim config? No, I just worry that I'm gonna like leak stuff that I don't want to in there. But I can tell you what the theme is. Theme is it's kind of fucked up. It's the Sonica. Oh, oops. What the fuck? Color scheme. How do you fucking? Here you go. It's the Sonikai color scheme, but with term GUI colors off. This is what it's. Oh, sorry. This is what it's supposed to look like. And then I have this. Add. Oh fuck. Sorry. What state do you live in? You've always been interested in our accent. Vancouver, Canada, which is sounds a little similar to like Oregon and Seattle, but like I think we have like a little bit of a Canadian twinge to it. Um. So I guess maybe instead of trying to limit like the number of initial balls by the height, maybe we should limit them by like the total area. So we want like num balls probably to be like we want like ball area is pi, what is it, 2 pi r squared, right? um and then if we're trying to say our ball area out of like the container area, with the pi's cancel out, so we go like ball radius times ball radius, the container radius times the container radius divided by the ball radius by the ball radius is should be the total area, the like the number of balls that need to be yeah, I think that sounds right. Number of balls that fill up the ball. Um and then here we can just say for 0 to num while ball ID is less than num balls, I guess. And then here we need to clamp this, the ball capacity. Yeah. That should do it. So we should just be able to do this. Sounds right. Seal this probably. And then do like as use size. You guys like that line of code? You guys like this shit? I don't. This is awful. Oh fuck, I refreshed chat instead of this. There we go. That seems kind of reasonable. Okay. So now if we reduce the ball size, okay, what if we go smaller? So what's going on here is like some like off-screen shit, I bet. Right? When they get too small, they're like instantly crumbling, right? Well, why? Like, what the fuck happened there? It must have to do with some of them being inside the container wall at first. And so they kind of like shoot outwards, which maybe pushes some stuff up. Maybe. Which kind of sucks. We could try to dodge that section. I hate those dual ads per inline casting expressions. Yeah. I was talking to Mlug about it the other day, and he said it's like a known annoyance, but I don't think they have a fix in the pipeline right this second. Just spawn them inside. I mean, that's how we started. That's how we started, and we were having problems. Why? I don't remember. I think that there was a problem there, but I don't remember what it was. It was something to do with as the ball size got too small, it stopped working right. But now I'm struggling to remember why that didn't work. I'm struggling to remember now. I wonder if we can easily get back to that scenario. Let's commit and try it again. Because yeah, I do feel like it seems simple, and the fact that I don't have a reason why it doesn't work means that I should try it again. So num horizontal cells should be this, and then the initial height should just be ball radius. Yeah, it was this. It was that because some things start inside the container boundary, the container then shoves those things up, right? And that propagates all the way to the top sometimes, and that causes like that causes this, right? Where these guys get like knocked out too early because of the fact that these are like shooting up. But maybe that could be offset by just allowing more rows. That's kind of cool. It's pretty sick that this is like the math here is not really that complex. And it's really cool that it just kind of works. Like I love like emergent behavior where like you get like lots of cool stuff happening out of, you know, not that much. Like yeah, I guess we could just like multiply this by like the number of balls. We could just multiply all of this by like 0.5 or like 1.5. Right, this was also happening. Where I think like the same issue. Mm, yeah, I think in this scenario, like some things get pushed in, some things get like down, some things get pushed up. All of these guys kind of like compress into each other and immediately pop back out because like they're like I can't fucking fit, and I think that causes like immediate just like goodbye. So I think that's why we didn't do it that way. I guess we could also space things out a little bit more horizontally, just give kind of more room overall. And then Yeah, I almost want to give it like a lot more, to be honest. I don't know how these two things cancel out then. How do we fucking center this shit? Uh, like cell horizontal cell size ratio or something. I guess we do kind of like this. And then we call like cell size is going to be ball radius times 2 times cell size ratio. Okay. Num horizontal cells then becomes like 2 times the container radius over the cell size. Sounds kind of right. Why not add an event hook to spawn one by temporarily clicking on the thing? Because eventually I want the goal of this is to eventually rip a bunch of simulations in a row and graph the number of balls that fit. So I want it. I want this thing like the like web page thing is almost only for debugging. Eventually, we're gonna run this in a program and rip a CSV or something. Rip into a CSV, I should say. Okay. So now this is this number of balls now should be related to um 2 times. Sorry, I'm thinking. If we're doing radiuses over radiuses and now we have diameters for cell size, I guess that means that we want to do 4 times container radius over cell size times cell size. I think that evens out. We do really like vibes based math around here. We don't really like, try to really figure out the answer. We just kind of punch a number in and hope for the fucking best. Okay. So these guys now move by the cell size, and now this just gets offset by something else. So if we are trying to keep halfway through centered, it's gotta be this. It's gotta be. It has to be. It has to be. That feels kind of right. That's crazy, actually, that worked. The initial sizing, the initial amount is wrong, but at the very least, the centering within this thing is working okay. Sure, blaze it. So we just have to fix this. No, this. So we did we want enough cells to fill 2 times container radius times 2 times container radius, which would be 4 times container radius squared, right? I don't really see why this is a problem. I don't understand why this is wrong. Right? Because we have like cells. Boom, boom. We're trying to pack cells into big square. Big square has width of 2 container radius, height 2 container radius. This has width, height, cell size. So if we want, how many of these things do we need? We need area of big square over area of small square. Area of small square is CS times CS. Big square is 4CR squared. So 4 CR squared over cell size times cell size. Seems fine to me. But I mean, clearly it's wrong. But I don't know why. So like, can we just like, can we like write down the calculation? So we want like, what, cell size is this, and CR is this, and numballs is this. So cell size, container, radius, globals, numballs. And I guess I don't need to new line in the log message. The new line comes for free. Hello? Where are my loggies? Where are my loggies? No, but like for real, where are my loggies? Oh, oh, we're in release mode now, so probably info logs are clobbered. If we go back to debug mode, yeah, here we go. Okay. Numballs 74. So first of all, are we seeing 74 balls? 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7, 8. That's 72, 74. So we are showing the right number of balls, and just for some fucking reason, we're doing the wrong thing. Why? Okay, so we have cell size 46.8, container radius 200. So if we were to do that math by hand, maybe Python is the play here. 200 times 200, 40,000. So we say this is the like container area. We have the cell area is 46.8. Okay. Container area over cell area, 18.2. The fuck? Oh, because container area is, sorry, it's 4 times 200 times 200. So that's 74. That lines up. The math is like, the math sounds sane to me. We just, maybe the layout's wrong? We might, yeah, if we're putting too many per row, that could explain it. What are we trying to achieve? Sorry, I'm dummy. I mean, I don't know if we've really explained it. We're trying to count, we're trying to see how many balls fit in a ball. Right? So we've written this like physics simulation. We spawn some balls, we let it run, and we're trying to like pack this ball up, which was happening before. Eventually, we're trying to graph for each ball size how many balls fit, and that will let us finally answer our silly little math question of what is the average distance between points evenly distributed in a ball? Because we need that for something. We're not going to go into the details there. Yeah, surely this is wrong. Or maybe this is wrong. Let's think. So, well, it doesn't matter what the offset is. It's the num horizontal cells that would have to be wrong here. You know this has probably been solved mathematically once or twice with actual formulas. Yeah, but when I Googled it, we Googled put balls in bigger ball. How to get huge testicles. So, I don't know. I couldn't fucking find it because I didn't try very hard. Because this is more fun. Okay, don't search that. But like, it seems like I just wanted to know the formula. You know, it's like I think it's like a sane thing to Google. I don't know. You might have given like an actual answer, so I deleted it so I didn't accidentally read it. Giving the answer, no fun. You can look up sphere packing 2D. That's not the point, though. I was kind of joking. Like, obviously, we could find the answer correctly, right? Obviously, this is all for naught. But, I mean, I think that there's like an actual, like, I think doing the work yourself has value, right? The fact that I don't know how to solve this right now is like something that I need to work through. And I think that this is kind of a fun way to do it. You know? I'm okay. Every step of this chain is like something that is fun and like useful anyways, right? They're all things that like, well, I guess like the thing itself is not useful, but having the skills to quickly whip up a physics simulation to test theories on like something like, you know, we could probably have done this whole thing without the physics sim, right? But like I'm like I want a way to validate that I'm right. You know, how else would I validate that I'm right? It's like I don't having these tools in the box I think is actually kind of fun. Is gravity a requirement? I don't think so. But gravity seemed like a free way to get type packing to me. What a ludicrous perspective for an engineer to have. I work with essentially none that would say such a thing. To be fair, I wouldn't say the same thing at work. Right? Like, how do I say this? If you were to spend company time just fucking around on something that you could easily find the answer to, it's almost like stealing. Like not really, but like kind of, right? They're like paying you to do something and you're just like not doing it. This is not a for-profit project. Yeah, exactly. Oh, you're saying, or unless you said you were the guy who said at work. This is not for project. Yeah, in fact, on stream, what's kind of fun is that there's like this kind of like fucked up reverse incentive where like solving a problem is actually worse. Because like the fun of the stream, at least in my opinion, is like working through the problem. And so like you get to indulge in stuff like this. It's actually good, which is kind of fun. Especially something like isolated like this, unless you take a break from a larger project that's harder to follow and just jump into like one small thing, boom, let's go. Okay. So what am I trying to do? Like I guess you could argue here, just looking at this, that the amount of push that we are giving to from the border is just too high. It's like guaranteed to cause instability. We might want to like apply a maximum value on the impulse of a border collision. Which we don't really have like a good feel for like what a good maximum would be. But it's probably related to the intersection amount. So intersection amount must have some sort of cap on it. Global's ball radius. So global's ball radius is kind of like our maximum value here. So here we should be like intersection amount. I mean, we could just lower this. Even that's a little high. I guess we want like the distance to stay there though. And maybe we do like this intersection amount over 10. And by max, I mean min. I want the maximum value to be this, not the maximum of the two. Yeah, that's a lot better. I mean, it's still a lot. We could even go lower. I guess I have to build. And if it's enough to keep us contained, then we're kind of chilling. I bet you that'll help a lot. Yeah, I bet you that'll help a lot. I mean, we could even go lower, to be honest. Yeah, that seems like maybe good. Okay, now we just have to pack more balls. Which we had the wrong size for some fucking reason, which I don't understand. But for now, let's just crank this bad boy up. Okay, which of these like 80 brackets do I put the times big number in? There we go. Oh yeah, that's wonderful. I guess you can tell here that we have kind of not the push is too small now because the pressure from other balls is not like it's not enough to overcome the pressure. By the way, this does not look like an over accurate physics engine. You don't say. You don't say. Wow, that's crazy. Um, yeah, maybe. I wonder what's going on here. That's weird. That's kind of strange. Maybe that's fine, actually. That feels okay. Um, yeah, fuck it. I mean, not perfect. And then also, again, we need to actually calculate this number of balls correctly. But that's not that bad. Not that bad. Oh shit. Oh shit. My whole browser's gonna crash at that point. Um, sure. Fuck it. I think that we probably have something that's like almost good enough to start actually just like using. It doesn't have to be perfect. We don't need it to be perfect even like relatively. We just need to fix this number of balls calculation, which is probably just like there's probably just some like yeah, that's oh interesting. Oh, because the number of balls now is like related to cell size, but we actually want enough balls to pack the entire sphere or the circle, which is not related to cell size actually. This is related to we should go back to using the radius here, which is kind of interesting. But maybe that times 1.5 is too much now. Yeah, I mean that's pretty close to sane. I guess we could do a little bit more. We could do a little more. Yeah, fuck it. Oh, fuck. You know what the problem is? When we reinitialize, we don't clear the velocities. That's why when I refresh, the behavior is different than when I move the slider. Oh, that makes so much fucking sense. Hold on, we need to just we need to clear the velocities. That makes a lot of sense. And then let's go optimize. All right. A little concerning that some of them just like insta, like, what's going on here? Oh, probably the initial check. The initial check for if the balls have like are going in towards the center is fucked up when the velocities are initially so low, probably. Do we do that check before we increase? Okay, we do apply some gravity acceleration, which means that the like border collision checking should work. I'm a little confused about where everything is going on this one. Right? Like, what the fuck is that? Um. So that's probably. Can we just make our step slider? Maybe we can use a different type of input here so that we can be a little bit more precise. So we can like really slow it the fuck down. What are our like options here? Number? Do numbers let us input floats? Um, like, am I allowed? Probably, yeah. Probably. So was it 24? Uh, First of all, it's like, sure. So we can really limit this. So this guy's just like, this center guy, there's some form of like floating point instability probably that's causing him to just like fucking go crazy. So probably a velocity cap fixes that. Like it probably fixes it enough. I think you should apply drag after apply velocities. I think it shouldn't really matter. Like all of these things are gonna happen like like they're gonna like jump to the next frame, and the same loop's gonna happen in the future. I don't think it really makes much of a difference. I could be wrong. I'm wrong a lot, but I would think that it doesn't change that much. But can we just like apply velocity, like cap velocities? Probably no delta needed. Uh, Probably something like this. So we take like the length, and we say like if this is greater than like velocity cap, we say that like velocity divide equals by probably times equals by velocity cap over mag, I think. Something like this. Probably something like this. Doesn't really seem to be doing shit, huh? Surprisingly. Although it does seem to be having an effect on most things. I could have been wrong about like the root cause there. Yeah, interesting. So that's seems to not be it. So then what is happening to this guy? It must be related to border collision, and it must be that this impulse is like through the fucking roof. Where it has to be. It has to be. I mean, we can just look and like see if any of them look fucked up. Fuck. 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 Oh, I control shift. Dog damn it. It was 24 0.005. And then I guess we go back to debug mode so we get the logs. Okay. That would do it. Check logs. Thank you. You know, you really saved me there. Okay. So nans. Nans. Seems bad. Seems bad. Towards center distance. Okay, let's look. Yeah, we look for divisions in here. Those are likely candidates. So, center distance. If center dist is less than some epsilon, return or continue. There's nothing to do here. I assume that's not it, but wait, is that actually it? Oh, wrong way. Okay, so that wasn't it. Okay. What's next? What's next? Other divisions are the scary parts. So dot product. Okay, length. No, it's multiplications and adds. Dot. Multiplications and adds, of course. So then the only other thing here is like delta. I guess we'll just log everything. Towards center vector is this. Impulse is this. And I guess the intersection amount. How much of these guys overlap in? All of them? Is our position also just like fucked? Is it possible that we applied some sort of bogus impulse on a previous iteration? Okay. Oh, but I guess, I mean, that's... Why is this log happening 99,000 times? Or sorry, 9.9900. Like, surely the same exact impulse shouldn't be applied over and over and over and over again, right? Surely. Oh! We're dumb pieces of shit. This is applying on all balls, not just the ones that are part of the simulation. Oops. We gotta be careful with that. Oopsies. Although that, did we build? We did. Although that doesn't fix things, we should be careful that we're not doing that anywhere else. 0 to none balls. Okay, let's just click acceleration. Globals, ball velocities at ball index. We're not gonna talk about it. Okay, border collision. We're looking at numballs. Okay. Ball collision, numballs, numballs. Okay. Drag. Numballs. Hell yeah. Velocity. Numballs. Okay. Although that is not the problem, that was scary. Let's take a shot every time he says balls. Okay, so now at least we don't have that bug of like the same fucking exact log being logged 9,000 times. That's a big win for us. But we still are seeing this. So it means some ball ended up with a position. It could be the position of nan was the real first thing. How does it apply? Applied velocity would be where the positions are set. So this is literally just like a oh oops, wrong one. This is literally just like multiply delta by ball velocities. So can we check which one of these got nan first? I guess we can say like if ball 0 is equal to like is nan. If this is nan, and I guess we'll say like ball nan is this, or position nan, I guess is a better word. But then we check velocity nan. Hello? Probably just bugged out language server, it's fine. If pos nan is not equal to vel nan, we say nan propagation, and we log both. Christoph, thanks for the raid. What's up, you guys? What is up, you guys? We are working on. Hold on. Just let me finish my one train of thought, and then we'll get there. Here we go. We are working on a physics simulation, which is supposed to help us understand a little bit of math, because we're shit at math. But the idea is we want to calculate how far the average distance between 2 points in a ball would be. I, in my brain, was like, I don't really know what the math for that would be, so I want to look at a graph of how far these things would be from each other given a certain like number of points that fit in a ball. I was like, I guess we could just like run a physics simulation, drop a bunch of balls in a bigger ball, look at the distance between them, graph that, then we can see like the shape of the graph, and then we can, you know, do something with that, right? So that's what we're working on. Physics simulation is a little bit unstable right now. We're just trying to slowly debug why. Very slowly. Yeah. That's the play. How do I fucking I guess I should just get rid of that other log spam. So our suspicion right now, well, not our suspicion. We are seeing nans show up, and we're trying to figure out where they're coming from. So it looks like the velocity gets set to nan first. Anyways, thanks for the raid, Christoph. Hope you guys had fun over there. Which means that one of these many guys is doing something stupid. Drag. Ooh, could be drag if the current velocity is 0. If the current velocity is 0, we would divide by 0, which would be bad. Which is it. Haha, okay. Nice, just a little bit of a little mistakeys there. We just have to say, if const mag is this, if mag is less than one, like it was very small. No drag to apply. Or continue, I guess. Okay, so can we crank the speed up and then can we play with many ball sizes again? Okay. So now we're back to the problem where like certain ball sizes are resulting in. Are we just running out of balls here? Like, what's going on here? What is going on here? I guess nothing crazy. I guess it's literally just that we like somehow don't have enough. Which we've looked at this calculation several times and we know that our calculation for how many balls to spawn is just wrong. We know it's wrong, so we should just fucking try to fix it again. Although I didn't understand why. So num balls, container radius over ball radius. Okay. And I guess what's happening here is that like if we say we want enough balls to fill the container, I think it's more that we want enough balls to fill the like square that the container fills, which makes me think that this guy needs to be like times, what is it, pi r squared? So we have area of square over area of circle. Except somehow that's making it even worse. Am I fucking high? Because I want the number to be bigger. But this doesn't make sense to me to do it this way. But you can't deny that those are enough balls. But it doesn't make sense to me. It does not make sense to me. Num balls. So we have container radius is the container area is maybe because there are a lot of balls that just drop outside the container. Sure, but like we should be able to fix that, right? Like if I have square like this, circle inside square, right? If we just like if we spawned enough balls to fill the square, surely there's enough balls to fill the circle, right? Surely. So why is that? What are we doing wrong here? Is the question I want to answer. So container area is pi container radius times container radius. Ball area is pi times ball radius times ball radius. Container square is container radius. Like, am I? Oh, 4 times container radius. There we go. So we do 4 times, and then so we get the container square over the ball area should give us number of balls that would fully fill the square, which maybe is sane. I mean, that's way more. That's clearly way too fucking many. Like, way too many. I have 1 pi too much. Oh, I missed that. Thank you. It's because the line of code is so fucking long. There we go. Okay, maybe that's right. Do I have like some multiplier on this by mistake? Eh. Feels right. I guess we could do something else instead. Also, we could do like maybe like ×2 here instead. So we could do like over the square that a ball would fit in. So this should give us something that approximately fills. Okay, can we make the ball size bigger? God damn it, god damn it. Okay. I guess it's because I've put gaps between, so it's just hard to kind of reason about. Could be. Yeah, so fuck it. I don't know. We don't have to get too crazy. So if I like start reducing the number here then, that seems pretty sane. But then there's not enough. Right. And then why would I get like really small? Is it just because there's not enough? Is that what this is? How many balls are there here? It could just be that we're running out. $1,600? It's way less than our capacity. Dude, I feel so fucking mental. I feel like actually like fucking insane. Okay, let's go back to doing pi r squared here. So this, we want enough balls to fill the fucking square that this thing fits in. Now we get, I mean, maybe that's just like a right number. I don't fucking know, man. And then my computers can't, oh, maybe we do release fast? Can we just like make this number bigger? I mean, maybe it's fine. Yeah, I guess just kind of fuck it. I guess just kind of fuck it. This is probably good enough. This is probably good enough, right? As if I crank this ladder up, we fill it, we fill it, we fill it, we fill it. I mean, it's probably good enough. We don't have to. We shouldn't be too picky. Let's pick like a sane lower bound here, which is probably 5. And then let's, I guess, try to actually graph it. This is probably good enough. Probably good enough. Good enough. Okay. Let's, I guess we need to refactor this a little bit to make it runnable from like an executable, not just from like WASM context. So can we call this like simulator zig? Beligo, thanks for the raid. What's up, guys? What's up? Okay, so we just basically need to pull like all of this code into here and then kind of change it from like globals everywhere to something else. We could probably also like get rid of some of these like fixed size things. We could probably use like a array list here or something. So we'll get rid of like WASM stuff here. None of this is part of this. Anything that was in globals now just becomes like a member function or a member variable for now. I guess we'll just leave things with fixed sizes for now because it just makes our lives easier. So probably something like this. Okay. Then Now this thing needs to return a simulator. So we go simulator is equal to this. Seems like size 5 gives the same result every time. Is it predictable to the simulations, no variation? I would bet yes. I don't think that because the layout is fixed, and I think that with a given step size, you're going to do the exact same math. I would assume. There's no randomness introduced intentionally. Okay, so I guess maybe return this thing heap allocated. That's probably easier for now. It's probably easier for now. So this is a try. We make this like this, and then I guess we, for good measure, write error here. Then we do initialize this thing. So we say ball radius equals ball radius. Put dots on all these. Sure. It's good enough. Container radius is container radius. Boom. Memset ret ball velocities now. Num balls here. Oops, sorry. I guess we kind of calculate this stuff up top, which means that we can then just say const num balls here, which gets put here. I guess ball positions and ball velocities. We probably want this to be 0, 0, and then positions to be I don't care, probably. Because we're going to lay the ball positions out below. Okay. Chill. Okay, boom. One function down. So now all of these guys need to take a simulator. Okay. This go away. And probably we just go like everything that says globals, we just replace itself. I would bet. Okay. Then we just start slapping selves in here. Nice. Straightforward, actually. It's actually easy as fuck. Okay. That's actually crazy easy. Now in WASM, just, okay, we're chilling. We say simulator is like this. We import that shit. Chill. And then on init, all we have to do is call simulator is equal to simulator init with stood heap wasm allocator, container radius, and ball radius. Catch. I guess we'll just log for now. I don't really give a shit. Failed to init. Smile. All right, and then we just like change all of these guys to pass-throughs. The tap man, thank you for the prime, much appreciated. So step now is literally just like simulator step delta. And I think literally everything else just goes in the trash. Nice. What's all this? It's probably all goes away as well. Yeah, it's like a maybe. Fuck. WASM 42. Return. Okay. Everywhere that says export in here, get that shit out of there. Nice. Surprisingly, things work. Less surprisingly, they don't actually work. Right, because we were kind of using globals here. Which means that we need to fix that somehow. How the fuck do we extract the render buffers here? We literally just need like num balls and ball positions. I wonder what happens if we do like ball positions equal, like, can we alias this? Like, what if we do like ball positions is a C pointer to simulator dot to F32s, and we say this is I guess we'll just take these things out of globals. This is easier. So this is going to return a C pointer to F32, right? And we just return simulator ball positions like this. That's easier. And then in index.js, here we say that this comes from after initialization, yes, which is done here, we should be able to call ball positions here, and everything else should behave exactly the same. Same with num balls. I think this is easier. Fuck. Okay, sure. Num balls, he says. Great. Attempting to access detached array buffer at index.js 107. Oh, because the memory view? No. Oh, maybe because on init we actually run an allocation which moves the like WASM memory. Yeah, okay. So now we have this thing that has 0 elements, which seems bad. Yeah, that seems bad, because this seems like it should be set correctly. Seems like it should be. You can just use a many pointer interacting with C. C pointers are for auto-generated code that doesn't know that it should be a singular many pointer. That's a good point. It's a pretty good point. Does num balls return a pointer of the actual value now? I guess it returns the actual value. That's a really good point. Good eye, good eye. Much better. Now the question is these right? We see that like these things start with 20s interspersed, which makes me think that at least the initial value is right. With 1024 balls. So if we start resizing this shit, 304, 120. I think that trying to fit, surely the container size here is wrong now, right? Like before we were at size of like 80, we were fitting like 4. The fact that there's 64 in here seems like really suspect. Right? Like, surely that's a problem. But I don't really know how. Numballs. Yeah, so 8, there's like a multiply by 8 somewhere that shouldn't be happening. True. True, there is. Now this makes sense. Now the question is why the fuck aren't they rendered? I guess on every init call, we probably need to reset this stuff as well, huh? So we probably want to do like async function, maybe just like function, reset. Re-init, maybe? Num ball size, I guess. And it's probably this. Boom. Okay. And then here we should be able to feed in the ball size here. Okay. So we read it once with ball size slider value like this. And then this guy should call reinit instead. Okay. So now, hopefully, if I start like, let's start looking at the render frame section. Why is this broken, right? So we should look at console log here. Just to see. Okay, so that's really bad here. He's getting 0 here because this guy is doing the same shit that we were doing before. WASM instance exports numballs here is what we want to call. Okay, cool. So now that's working, but the positions are wrong. So why? Am I high? Maybe ball radius is wrong? Aha! Ball radius was being pulled from WASM before, and that is no longer reasonable. So we should do this. And then we need to replace this with the WASM function now. Okay. There we go. We're so back, baby. Although, when we resize, balls is now broken again? Which is confusing because every time we re-init, we are supposed to refetch the current memory positions. It's kind of confusing. Today, what are we working on? We're working on a physics simulation. We're just trying to figure out basically how many balls pack into a bigger ball, and instead of doing the math, we were like, let's simulate it. And we are just we had it working okay. I think if we get stash here and rebuild, this was kind of what we were looking at, right? So we were trying to basically run this. Well, we want a graph for each ball size, how many balls fit in the bigger ball, because I was when I googled the formula for packing balls into other balls, I got a lot of stuff about testicles. And so we got to the point where it was like kind of working. We're now trying to refactor our Zig code so that we can run it in a loop, spit out some CSVs, instead of running it in the web browser in this like interactive way. But it looks like we've made some mistakes in that refactor. And the question is, why? Why? The 5-head move would have been to reorient your project towards testicles. Yeah, that's a really good point. I should have, huh? Obviously. Do I not reassign? Wasm shouldn't need to be reassigned because he's instantiated one time. Oopsies. You could argue that when we re-init... Oh, I'm just a dumbass. Just fucking typed reinit twice. Okay, that's a little better. Although I don't understand now why the number of balls is fucked up again. Didn't we fucking fix this? Right, am I high? I thought we fixed this. We did this. Are we not rendering them all? We're supposed to have 600? Yeah, these sizes match. Which really indicates that, like, the num balls calculation is wrong, but I swear to fucking God that we fixed this. Like, this sounds really familiar. Bum 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 bum. I guess we just do this and fuck it. Yeah, I mean, it's fucking weird, man. The fuck? Oh, I guess maybe... Fine. Fine. We'll just do 2. And we'll just be like, this is slow as shit. But that's fine. Math is really pretty easy. You can make a really close approximation pretty easily. Yeah, that's my guess as well. That's my guess as well. But I wanted a way to check my answer. And this is clearly the best way to check it. Yeah, I wasn't sure, just like initially, if it was gonna be like radius related or area related or like something else. So I just wanted a way to check. And it's kind of fun. It's a fun excuse to do this. You know, where are these like log spam coming from? Index.js maybe? Because, you know, usually, generally, the reason we're really using things, we're making excuses to do things more often than we're actually trying to solve problems. Right? So, like, you know, maybe, like, the reason is never, like, untrue. It is, like, a thing that we want to do, but we're okay taking a very roundabout solution to get there. Okay, that seems like it's working good enough. I guess if you want a real answer, the simulation is the way to go. Not sure if the math way to calculate this. Not sure if there is a math way to calculate this exact answer. There has to be. There has to be a math way to calculate this. I'm sure of it. It's got to be something like you have some sort of average per number of balls. There's got to be some like ratio of like space to balls in like a perfectly packed scenario. And then I'm sure that like you take this area of a circle and like divide by that ratio or something and get the right answer. But this is a fun answer. This is a fun way to check that. Okay. There we go. Okay. So let's, now that we have this simulator broken out, we should be able to make like a on disk executable that isn't like something that we run in WASM. And in here, we should be able to do like simulator zig, right? And we should be able to go like, let's initialize this thing. And let's just make sure that we use the same parameters as we're using on WASM land. So we had container radius of 200. And then I guess we want to run this like, let's start with like 20 at first and just kind of see where that kind of goes. We need some sort of allocator. How the fuck do you do this? Stood. Stood heap general purpose allocator. And we probably defer this shit. And then we get the runtime interface. We feed the runtime interface here. We call it sim here. Defer, probably alloc destroy sim, I guess. Okay. And then we need to run till completion. And this is going to call sim step for, I think this is our step size. Yeah. So we say like, while some condition not finished, I don't know. While running, while unstable, sim, I don't know, man. While circle, like not packed. I don't know, man. We step it. Okay. And then can we then figure out what not packed is? Okay. So I guess we go for 0 to sim numballs. We probably want to look for like their velocities or positions in some way. No spoilers. Sorry, I just deleted a message that said what the packing between elements was. So like here it must be, we can probably say like, we can check if like all the ball positions are below the bottom. Didn't know you're going to calculate it. Sorry for that. No worries, no worries. Is there both function and fn in Zig? I think function is when we're in JavaScript. This is JavaScript down here. This is Zig up here. I don't know what I'm doing here. Yeah, we have to. What's the exit condition? It's that like most of the balls are below the top of the container, I guess. And the ones that are above the top of the container have a very low velocity. I guess is the exit condition. So we say like all balls below top of container or have very low velocity. Wikipedia has an entry on this if you want it when you're done. Hell yeah. I do want to check against the real answer when we finish. But I think it's just fun to do the whole exercise as well. Okay. we probably want to do like, 1,000 steps at once or something. Maybe like 100 steps at once, just so that if the packing calculation check is expensive. So this has to return a bool, returns true at the end, and then I guess maybe it returns false at the end, and we exit anytime one of these conditions is hit. So we say if sim ball positions at ball index dot y is less than container radius times 2, or greater than this times 2. And and the velocity is low. Where length comes from, I guess, simulator. We're getting cheeky with it. Who cares? Is less than like 1e, like 1e negative 5 or something. I don't give a shit. If this then it's good. So we're trying to look for the exit condition here. We're looking for the return. We're still running. So if there's a thing above and its velocity is greater than this number, that's when we still have more work to do. Yeah. And then if every single ball passes this check, then we're done. And then we probably just have to be careful about this like number. And we also have to be careful with the initial steps. So I think we actually have to do this way. So we'll actually say this is packed. We'll say that the like sim ready, I guess we'll call this. And we'll insert this. Then we can say if sim ready break. Because that way we'll have done at least enough to get the balls moving. Yeah. Sure. Seems good to me. I guess we need to add this to our build script now. Just check if the number of circles in the main circle didn't change for like 1 second. Yeah, that's not crazy either. That's probably easier. Maybe if numballs below container doesn't change, that also makes sense. Those are both probably better answers than what I just did, huh? Name equals sim. Root source file is b path source main. Target is equal to, we'll call this WASM target here. Oopsies. WASM target is this. And this is just regular target. Optimize equal to optimize. Okay. Now we need to get our target. So standard target options. Okay. And we install this. More magic numbers than David Copperfield's bank account. Love it. I mean, I think that like the reason that magic numbers aren't great is because it's like hard to keep track of them. But if we know what they are, then we're chilling, especially in Scratch code. Who gives a shit, you know? Okay, let's see if this ever exits. It does. Okay, so then can we maybe just for sanity, maybe we will count. Oh, maybe we actually have to run till completion, actually. That's probably the bigger problem. So he's pissed. Does not support field access. Yeah, that's true. This is 1, not Y. Okay. 1 Mississippi, 2. Yeah, I mean, no, that's probably kind of correct. That is kind of correct. So let's. Can we log how many steps this took? This many steps. Okay. Sure. And then if we reduce like this down to like 5, like how bad is this? Can we do this with release fast? Actually, what we should do here is we should every like 100 steps we can do a little we can do a little update. We can write down. So this is stood io stood out writer. And we can say carriage return and we can just write down num steps. And then probably before we do any of this, we should probably write a new line, probably. And then at the end of this, probably do this. Error unit is ignored. Fuck off. I don't give a shit. I don't give a shit. You can't make me care. It's crazy how long that takes sometimes. Oh, interesting. So probably because of we're doing like an n squared collision check, because we're too fucking lazy to like localize this shit. It's taking way longer. And probably I would bet that we're actually done. And probably using another heuristic like you guys were suggesting is probably better. So maybe we do like previous in container is equal to something. So maybe we do this in like a structure. Sim checker. And this is like previous in center in container is a u size equals 0. And then we say is ready. And this returns a bool. And we just, this takes in self as well. And I guess this probably can just store the simulator here as well. That's easier for us. So we can just go like for self sim ball positions. It's actually for 0 self sim num balls, ball index. If I don't know, ball positions, ball index is in container. We count these. Okay. Then self prev in container is equal to in container. And then if in container not equal to self prev in container, return false, return true. I guess this is return this thing directly is what we were actually looking for. Chillin'. Now we just need is in container. Vector to floating point 32's bool, and we just go like container center is equal to we could probably move this logic somewhere, but I really don't care. I really do not care. But we maybe might want to note probably duplicated. Right. But the container center is vec2 of 0 and container radius, okay? And so we just have to do like container center minus pause. Like this thing. If the length of this is greater, less than, or equal to, probably just less than, container radius. And we actually have to do container radius minus ball radius, probably. Probably. And maybe we'll give like some wiggle room here. We'll be kind of generous. That seems reasonable to me. Sure. Let's see if this gives us a somewhat reasonable answer. So I guess we need to delete this, and we say sim checker is a sim checker, sim equals sim, and then it's if sim checker is ready, and we can say no, like balls in container, and this just comes from this. Can we do this with like 20 radius first? $48 balls. Okay, let's see if that lines up with what we see. Okay, we're gonna fucking count them, dude. Sim speed 0. 1, 2, 3, 4, 5. Jesus Christ. Okay, here's what we gotta do. Hit me with the print screen. Hello. There we go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6. I forgot what fucking 10 I was on. We go back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83. Okay, so we're off by a lot unless our ball size wasn't 20. So we're probably exiting too early, which probably means that this has to be more steps or something. What would we say? 84 or something? Let's see if this number changes. Okay, 80 is close. It could be that there's some sort of like, you know, some amount of like difference in WASM version of the code versus versus our thing. So sure. Okay. So now, like if we do with 10, I assume that the number go up, up, up. Okay. Wait, this is maybe, we're actually maybe starting to get useful. Okay. Test on a smaller size will be easier. That's a pretty good point, huh? So 50, we get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that seems about right. WASM single threaded? Yes. But so is our thing. So is our thing. No threading involved in this. We're just fucking running a shit in a loop, dude. Okay. Sure, blaze it. Now, if we want to start graphing this shit, I guess we just run this for many iterations. You're off by 1, 11 not equal 12, but 8. I mean, you could easily see a world where a ball fits here. Right? A ball could fit in here. I'm not really too worried about it. I'm not too worried about it because like we're assuming that there are some slight differences because of like WASM floating point numbers versus our floating point numbers. Like realistically, you would think those compile down to the same shit, but maybe like constants in WASM land are a little bit like just initialized slightly differently, or maybe the JavaScript to Zig float conversion is a little different. So 0.8 is generous, but then it should be more. I don't know what you're talking about. Okay, so let's run this for like 7. 0. Let's do like 100 iterations of this thing. Okay. And we every time re-init the simulation. Oh, we actually have to make sure that here we probably have to do like fix me destroy simulator if exists. We've got like a leak there that's definitely happening in the WASM land for sure. For sure. But whatever. Is it in the container check had a 0.8? Oh, that's true. Because I kind of figured that there's like you could have something that's like slightly poking out. But yeah, you're right. There is something there. We probably want to start these things take floating point values, right? So let's like say that we have some sort of like start size is going to be we'll start like what is like a sane geez, not 0.7, Jesus. 7.0. Like it starts to get kind of slow. 7's pretty unbearably slow. So maybe we start at 8. And maybe we go up by like 0.3 or something each level or something. I don't know. So we want like I times 0.3 start size plus. Okay, and then we can do like ball size here, run till completion, and then we probably want some sort of like output CSV. Create file out.csv, and we want like CSV writer is going to be CSV writer. Okay, and then on each run we're gonna be like CSV writer write print, and we're gonna be like size to number. Yeah. So this is gonna be like ball size and sim. Maybe this will return like this. Okay. Sure. Let's see what that does. And then we need a new line here. And then hopefully this flushes every iteration so that we can start graphing as it goes. Bang today. We're working on a physics simulation that drops balls into a container, hoping that we can discover the relationship between number of points and in a circle and the average distance between neighboring points. So we are hoping that we can graph something that will tell us that there is some reasonable formula for this thing. The way it accelerates it is kind of fun. Okay, so we've written this like physics simulator, right? He drops balls in here, and we're just trying to figure out. We are now trying to graph the relationship between ball size and number of elements. Hopefully that will, in the hopes that will correlate with some formula that we can just punch in given a circle size and a number of points. That's kind of what we're hoping. Do I have like LibreOffice installed? Surely not. Like, when am I ever graphing stuff? So I guess like, is there like Google Sheets? Am I logged in? Is that going to be a problem? Can I use Google Sheets without an account? Do I just install LibreOffice? What do you think fresh means? Do you think it smells good? What does it mean? Who knows? It's unknowable. Is this fresh is stable and still is also stable? Okay, so fresh is less stable but still stable. Dude, writing this is the stable version, but the ones that has more features is like, okay, so you're kind of saying that you have two versions because you're worried it's less stable, right? Today we are rediscovering the work of some Greek folk. Yeah, dude, being those like Greek philosophers seems like so sick in some ways. You like sit down in your bathtub and some water falls out and you're like, holy shit, there's like a volume of water in here. And you're like a fucking genius because you notice that shit. It's so sick. Oh, it's CSV. Okay. Can we graph the shit? Alright. Um, how the fuck do you graph something here? Data. It's gotta be under data, right? Dude. Insert? Chart. Here we go. Dude, that's pretty fucking sick, dude. Can I change this so that the fucking x-axis is defined by the first column? Oh, is it scatter? Is that how you do this? That's so cool, man. That's so sick. That's actually so fucking sick. I know it's like nothing. I know it doesn't fucking matter. Like at all. But like this is like exactly what I was hoping to discover, right? There is some function that like fits this. Can we just like ask this to fit insert? Is there really no like best fit like formula thing to this? I thought there was. Maybe they. Oh, here we go. Wait. Here we go. Power. Wait, how do I know what it is? Tell me. Tell me. Let me. It's missing. Let me have it. Tell me what it is. trendline name, show equation. Yeah. So we have a square root, x to the power of negative 2.06. That's so sick. So does that make sense? Why? Why would this be square root? How can we like rationalize that? It's because the area, it must be like proportional areas, right? So we have like you have like there's going to be some ratio of like empty to full space, right? There's going to be some ratio of empty to full space when you like throw a bunch of bitches into the container. So we have like container radius. We'll call it outer. Is going to be. I guess we can just kind of fix this at 1. Can we like let's Can we scale all of these numbers to be like a relative to the container size? Right? So all of these guys. So then we graph this like this. X, Y. Do the columns need to be in order, or can I change this so that can I swap it? Like, I thought it was based off highlight order, but I guess not. Can I really not invert it? Oh, maybe like this? No, data series and columns. It's fucking backwards, man. Can I really not flip it? That's so shit. It's not squared, it's 1 over x squared. Oh, that's a really good point, actually. That is a really good point. I thought it was... yeah, because square root is x to the 0.5. Thank you. I'm an idiot. This is why we need fucking simulations, because I can't fucking do math. Okay. Insert trend line. Show equation. Here we go. Okay. Yeah, so we have like some ratio that's like approximately. You could, if this is like ratio of empty to full space, it might not be. It could be. Somebody else is saying that's like 0.9. I don't really believe that. I could be wrong, but like, can we look at like ratio of circle to empty space? Like if you just like, like this would be like a sane number to me. But okay, so let's say there's like some ratio. We don't really care what it is, probably. We'll say the outer radius is 1. And the amount of stuff that can fit surely is like some like ratio times, we'll say like inner ratio is the like ball radius, or IR, sorry, for ball radius. Inner. Surely this is something that's like R times inner radius is like how much stuff can fit out of the outer radius. Sorry, we need pi r squared over pi outer radius squared or something. Right? This surely has to be part of it. And so if we're trying to find out the inner radius in terms of the outer radius, is this how this works? So we say like this over this is 1? No. We need numballs in here. There we go. Numballs times this something equals the outer radius. Yeah. the outer area, right? So this is the amount of stuff that we can fit. This is how big this stuff is. We'll kind of can take the pi out here. We should leave it in. Okay. That seems reasonable to me. So now where is this, like, the 1 over squared is interesting. I feel like there should be a square root in here if we're looking for, I guess the function here is numballs. No. The x-axis here is ball size. So we have some function that takes in ball size and outputs numballs. Outer radius is fixed, right? So since outer radius is fixed, we scale everything so that outer radius is 1.0. This is just pi. And now we have 2 variables to solve for. Two variables. So if we want IR on one side, we go like pi times numballs times pi times r times IR times r. There's literally no addition in here. But if we want, so that means that we divide to get like numballs times pi. The pi's cancel out, so we have like just numballs times r is equal to 1 over IR squared. And that's where this comes from, I guess, right? Because our function is taking radius and returning balls. So if we were to go the other way, we would say that, like, if we're trying to get numballs out, this is like this. Yeah, that makes sense. So we take this thing in, we have to go 1 over that thing squared over some ratio is numballs. Cool. That was a lot of time spent for a not very difficult answer. But that's pretty fucking sick. That's pretty sick. I mean, I think that it is so fucking cool. Like, so fucking cool that you can just do this. Like, obviously the math is also cool, right? It's cool that you can just think about it a little bit and get the answer. But it's also cool that you can experimentally check the answer by just like fucking like typing some numbers into your computer. It's like so fucking sick. Like, I'm actually like so happy. Like, again, obviously we didn't need to do it this way. This is like such a roundabout way to get the answer, which is kind of what adds to like the entertainment of it. But it's so sick. It's so sick. And now all we have to do is figure out, do we think that this 0.68 number is reasonable? Like, where does this come from? I think I've seen something about like 0.7 something. Probably that's related to like square roots. Like, what's like square root? Like 1 over root 2 probably is what I'm thinking. 1 over square root 2. Yeah, I bet you there's some bullshit related to this. So like just given, like, can we this seems like the type of thing that's like easier to ask AI, even though they're fucking wrong all the time. Given if we pack balls tightly into a container, what is the ratio of empty space to space in balls as we approach an infinitely large container? $74. So it could be that we're probably like over, our ratio is probably like fucked up because the ball size is so big. Is that true though? Where does it come from? Like, somebody said something about a Wikipedia article earlier. Wikipedia has an entry on circle packing. Let's look at that. right? Because like we're not anywhere close to infinity, right? Which probably makes this worse. There we go. Oh, interesting. So Claude is just like a fucking lying piece of shit. I mean, that's so funny. Why fuck? God damn it. Is our case ball or circle? Circle, I guess. Okay, this makes sense, right? You take circles, you draw a hexagon through their centers, and then you calculate the amount of empty space in between. That makes sense because all their centers touch. Okay, that makes sense. So then I guess the question is why is ours so different? I guess there's a chance that like this is so far from what we have, which makes me concerned. It's also possible that the line fit is wrong though. I think he has balls to Claude in his defense. Oh, maybe I did. Yeah, that's a good point. That's a good point. I probably did, right? Sorry. By balls, I meant 2D circles. Yeah, okay. So he is not a lying piece of shit. I just asked the wrong question. I doubt your sim is ending up with the optimal arrangement. Yeah, I agree. I agree. I was initially thinking that it, like, I really was more looking for the shape. Now, I guess the question could be, do we get a better answer if we work with smaller balls? That seems like very likely to be true. This is going to take a much longer time to compute, but I would imagine that with smaller balls we get a like closer to real answer. But I mean, with the ball that small, it's literally just like shitting itself. Can we go maybe like 6? Not even sure it could because he made the container circular. I was like, no spoiler. But like, I mean, I would imagine that eventually the circular container, like the amount of space that's taken up around the outside is like should become irrelevant, is kind of my thought. Like the smaller the balls get relative to the container, the less the container itself matters. There's a wiki on this, circle packing a circle. Circle packing in a circle. Ah, nice. Oh, wait, hold on. This kind of lines up with... These numbers are a lot closer to what we were getting, right? I mean, obviously our things are a lot smaller, but... Interesting. So it's not even linear, huh? It goes like up, down, based off of like the most optimal arrangement, I guess. Interesting. Okay, so now if we LibreOffice this one, do we get a different formula? So we were getting something around like 0.68, 0.69 or something, if I remember correctly. We need to scale all of these. What do we do? So this goes here. We do this equals this over 20. And then we, how do you do this? You drag this all the way fucking down here. And then you graph these two. And then, fuck. Then you click this, insert trend line. And we said it's power show equation. And this is 0.8. I mean, come the fuck on. Come the fuck on, man. That's so cool. That's so cool. So we get like a way bigger number. Oh, we're at 80? Why 80 instead of 0.8? 80 seems like a lot. Yeah, wait, what the fuck? Maybe I'm conflating two things. It's possible that we're also going like the other way, right? It's possible that because we're going the other way and something gets like inverted. Yeah, there's something odd there. But what does this number indicate? The number is bigger, which means that the ratio of balls that we can fit is bigger, which that lines up with my guess that smaller balls means more will fit for each level. Okay. I mean, honestly, to be fair, I don't actually care about the ratio at all, because this scalar, we can just determine experimentally what looks good for us in our application. So really all we care about is the shape and like an approximate number here that makes sense. Okay, so now that we know that this thing is like 1 over x squared, now we know that this thing is 1 over x squared, which we could have figured out very easily from the start. Where is our like Vim instance here? So if we want to go the other way, where we have a function that goes num balls to IR, we just have to go the other way here. So this is okay. So we want to get IR on one side, which makes this go IR times IR equals 1 over num balls over R, right? Because the pi's cancel out, and then so now we have IR is equal to squirt 1 over num balls, and like the R can just move up here because we don't really care about it. Maybe we call C. And if we, which we can easily check by just inverting the graph. And we don't even have to do that because we just know that like, I mean, we might as well. I'm pretty sure that that's right. But I guess we might as well double check. I was looking, if you're looking for a fun problem that you can later compare with math solution, try this. Double slit experiment. Dude, quantum mechanics is where I just gave up in physics at school. I was just like, I don't understand what the fuck is happening anymore. So this is equal to this over 20. That's what we said, because 20 was the container size. And if we just chart this the other way, we should see something that resembles... Is this still... Am I stupid? Why does this look the same as the other way? Am I mentally missing? Oopsies. Yeah, why are they the same shape? Isn't one of these square root and 1 over... Maybe I'm just getting confused. Would we say 1's like 1 over x squared? And then 1 we think is 1 over squared x? Oh, yeah. Which, and these are mirrored over x equals y. So that lines up. And that probably actually lines up with this too, because the acceleration's in the other direction. That's probably fine. That's probably fine. Which lines up with our math here. We're really doing vibes-based math right now, for sure. So, yeah. Yeah, okay. All right, sick. Sick. I guess I don't really want to do much else today. I'm kind of happy with calling it there. I think that we have made good progress. We finished up this ball simulator. I think I will probably post this ball simulator. I'll probably upload the code to this. I probably won't clean it up, but I will upload this here if you guys care about it. And I guess that's it. We'll be back probably tomorrow with like a real stream where we work on integrating this with our code map. So we now have the information that we need to draw some pretty backgrounds around some of these points. We can kind of now group some of these, and we'll see how that goes. So thank you for watching, guys. Thank you, Raiders, for sticking around. I hope you enjoyed what you saw. If you want to come back by, we'll be online tomorrow, 12:30 to 4 o'clock Pacific time is our typical stream time. It is 3:30 now, so anywhere between 3 hours ago and an hour from, and half an hour ago, or half an hour from now is when you should expect to see us. There's a YouTube link in the Twitch description where we throw up the normal streams. Right now, today was kind of more of a happy hour, we call them, which is kind of like we don't have much of a plan, but we usually have like a little bit more structure to like the mainstream. We do kind of like half this type of shit, half more organized, focused work. But today I wasn't really feeling it. So if you want to keep up with that stuff, it's organized into playlist. You can check it out. If you want the happy hour VODs, which are like today, they're on Patreon or on YouTube members, or if you sub on Twitch, you can see the VOD archive. Otherwise, I think that's all we got to plug. Let's raid someone.